Welcome to solverfy.
Given a description of a chemical reaction, we can take this description and write it in a balanced chemical equation by first identifying the formulas for the substances involved and then balancing by changing the coefficients. So for example, when gallium metal is heated in oxygen gas, it melts and forms solid gallium oxide. So we know that we're starting off with gallium metal. Gallium is an element, and when I look on the periodic table, the symbol for gallium is Ga. It's a metal, so that means it's a solid. It reacts with oxygen gas. Oxygen is a diatomic element and so exists as O2 in chemical reactions. It reacts to form the substance gallium-3 oxide. Gallium-3 is an ionic compound with a +3 charge, and oxide is the oxygen anion with a -2 charge. And so the formula for the neutral compound is Ga2O3. So the product is Ga2O3, which is a solid. So this is called our skeleton equation, where we have the substances written out. To balance, we change the coefficients. I have 1 gallium on this side and 2 on this side. I have 2 oxygens here and 3 oxygens here. So I look for the lowest common multiple of the oxygens, which means that I have to multiply this side by 2 and this side by 3. So now I have 6 oxygens on both sides, 3 times 2 and 2 times 3. This also changes the galliums. On this side I have 2 times 2 or 4, which means I need to have 4 galliums here. So the balanced equation is 4GaS plus 3O2G makes 2Ga2O3S. A second example has liquid hexane burning in oxygen gas to form carbon dioxide gas and water vapor. If you don't know what hexane is, it's a hydrocarbon, which means it has carbon and hydrogen. The hexane is a 6 for carbon, and there are 14 hydrogens. And this is a liquid, so we write L. It reacts with oxygen, which again is O2 gas, to form carbon dioxide, which is carbon with 2 oxygens, and water vapor. Water is H2O, and vapor is another word for gas. These can be a little tricky to balance, so we start with our carbons. On this side there are 6, so I'll put a 6 here. There are 14 hydrogens, which would make me think a 7 goes here, 7 times 2. When I look at my oxygens, I have 12 oxygens plus 7, or 19 oxygens, which is an odd number. So over here, I have a diatomic oxygen. So I can put 19 halves in order to get 19. But I can't leave it like that because that's not a whole number. So I then go through and multiply everything else by 2 to get rid of that. So this should be a 2, 19, 12, and 14. The last example looks at ionic compounds. I have solutions of calcium chloride and sodium phosphate, and they make a solid calcium phosphate as well as a solution of sodium chloride. So I have different ionic compounds that I need to find the formulas for. So calcium chloride is made up of the Ca2 plus ion and the Cl minus ion, or CaCl2. Sodium phosphate is the Na plus ion, and phosphate is the polyatomic ion PO4 3 minus. or Na3PO4. Calcium phosphate is Ca2 plus combined with PO4 3 minus, or Ca3 PO4 2. And finally, NaCl is Na plus and Cl minus, or NaCl. So to write the balanced equation, I have CaCl2, which is in solution, so we write AQ, plus Na3PO4, also aqueous solution, or AQ, makes solid calcium phosphate, so Ca3PO4 2, which is a solid, so in parentheses S, plus aqueous NaCl. And when we look to balance, we can see on this side, we'll start with our calciums. There are 3 calciums. So I'm going to put a 3 here, which makes 6 chlorines. So 6 here, and a 2 here to balance the sodiums and phosphates.